Hey, welcome back everybody. Today we're going to be drawing some Lewis dot diagrams for some oxyanions. Those are those charged ions that include oxygen, such as the perchlorate ion. As before, our first step is to figure out our total number of valence electrons. So the number of valence electrons from chlorine plus 4 times the number of valence electrons from oxygen plus 1 extra electron. That's where the extra electron is going to give us our total valence count. Chlorine has 7. Each oxygen has 6 plus 1. So here we've got 25 plus 7 makes 32 electrons, or 16 pairs. Next, we determine our central atom. Now, our central atom is typically the element that has the greatest bonding capacity, is listed first in the formula, and has the lowest electronegativity. So here's our first element, chlorine. It has the Lewis structure of 7 valence electrons. We expect it to form 1 bond, because it has 1 lone electron, and we expect it to have 3 non-bonding pairs. Oxygen, we expect to have 6 valence electrons to form 2 bonds, because it has 2 single electrons, and have 2 non-bonding pairs. Once we've determined our central atom to be chlorine, we're going to attach each of our remaining oxygens to that chlorine atom. Our next step is to fill the octets. Recall that we have 16 pairs of electrons to work with. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Huh, that checks out. Now, this is an example of a Lewis dot diagram that is not quite complete. This is where the review stage comes in handy. When we're looking at each of these elements, we want to understand that every shared pair corresponds to an electron originating from each of the parent elements. 2 lone electrons overlapping in space. When we look at an oxygen, we notice how there are apparently 7 electrons around that oxygen. This varies from the 6 valence electrons we know oxygen to have. So this results in a formal charge of -1. If we look at our other oxygen, the same is true. If we look at our other 2 oxygens, this is all true. So there's an issue with this diagram. You're supposed to have 1 negative charge, but here we've got 4 negative charges. If we look at our central atom, chlorine, chlorine has only 4 valence electrons around it. For our chlorine atom, it's supposed to have 7. The absence of those 3 electrons gives it a formal charge of +3. When we perfect in our review of our Lewis diagram, we're looking to minimize the number of possible formal charges in our diagram to describe the best structure. In this scenario, we can expand the octet of our central atom. Chlorine is a group 3 element, so it should be able to expand into its D shell, exceeding the octet rule. Let's see if by exceeding the octet rule we can create a better diagram. Now, if we were to introduce a single double bond between the oxygen and the chlorine, you'll note that in this scenario we have both eliminated the formal charge on the oxygen And we have reduced the formal charge on the chlorine from +3 to +2. By reducing the presence of the formal charges in our initial diagram, the introduction of a double bond here has, like I said, reduced the formal charges. If we were to find the best possible structure, our structure would be one in which we have 16 pairs of electrons One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 pairs of electrons. You'll notice that we have no formal charge on the oxygen, no formal charge in the oxygen, and no formal charge in the oxygen. All three of these oxygens resemble the oxygen that we expect to see. This oxygen carries a formal charge of -1. Our central atom, the chlorine, has 1, 2, 3, 4, 5, 6, 7 electrons originating from it. That's the same 7 electrons we were supposed to start with. It has a formal charge also of 0. So notice how in this current structure, we have 1 formal charge total. However, in our previous initial structure, we had formal charges all over the place. If we were to draw this diagram with resonance, we would draw all possible structures, which would include what you'll notice is that the negative charge doesn't reside on any one particular oxygen atom. When we draw the resonance structures, the negative charge is distributed evenly across all oxygen atoms. This is resonance.